In this session, we are going to discuss about the production of phenol. There are 6 processes are available. We will discuss the first 3. Right? We will see the different methods of production of phenol. Number 1, cumin peroxidation hydrolysis. Number 2, toluene 2-stage oxidation. Number 3, rashing process, that is hydrochlorination and hydrolysis. 4th one, chlorobenzene caustic hydrolysis. 5th one, benzene sulfonate caustic fusion. And 6th one, benzene direct oxidation. So first we will discuss the first 3, cumin peroxidation hydrolysis, toluene 2-stage oxidation, hydrochlorination and hydrolysis, that is rashing process. These 3 processes we will discuss in this session. First, phenol from cumin peroxidation. The reactions are, you can see the reaction, cumin or isopropyl benzene is oxidized in presence of aqueous emulsion in air, gives cumin peroxide. This cumin hydroperoxide is then subjected to hydrolysis process in presence of sulfuric acid, which gives you phenol and acetone. Here acetone is obtained as a byproduct. Acetone is obtained as a byproduct. Aqueous emulsion is prepared using emulsification agents. Operating conditions are normal temperature and pressure. Emulsification agent, sodium hydroxide, that is alkali. For hydrolysis, 10 to 25% sulfuric acid is used. The operating conditions are 55 to 65 degrees centigrade and atmospheric pressure. So this is the flow diagram for the production of phenol from cumin peroxidation process. The process is, cumin isopropyl benzene is made by alkylation of benzene with propylene. It is mixed with recycled cumin in 1:4 ratio and then sent to a hydrogenator, right? The unsaturated and alpha-methylstyrene are converted to saturated materials to avoid the undesirable decomposition of the peroxide during oxidation step. Hydrogen over nickel catalyst at about 100 degrees centigrade in a batch reactor is used for purification. Oxidation is carried out in presence of air in the oxidizer, here in an aqueous emulsion stabilized by an alkali such as sodium carbonate in the 8.5 to 10.5 pH range. The vent gases are passed through a condenser to recover the hydrocarbons. The cumin peroxide thus formed is cleaved in an acidifier containing 10 to 25% sulfuric acid. This is an agitated vessel at 55 to 65 degrees Celsius. The reaction products are separated into 2 aqueous acid layers for recycle to the cleavage vessel and an oily layer containing 76 weight% cumin, 14% phenol and 8% acetone and 1 to 2% alpha methyl styrene and acetophenone. This mixture is separated in a series of in the series of distillation columns, the last three of which are operating under vacuum. These three are operating under vacuum. Phenol is in the overhead of the last vacuum fractionator is purified by crystallization. So this is the process how we can manufacture phenol from cumin peroxidation process. In the cumin peroxidation process. The next process is phenol from toluene oxidation or toluene two-stage oxidation. Here the reactions are, we can see the reactions. Here first one is oxidation of to benzoic acid, that is toluene is oxidized to benzoic acid in presence of cobalt naphthenate as catalyst and a temperature of 150 degrees Celsius. So toluene oxidizes to benzoic acid and water. This benzoic acid is further oxidized to phenol in presence of limited oxygen at a temperature of 220 degrees Celsius and cuprous benzoate catalyst. Cuprous benzoate catalyst. The process here is two-stage air oxidation process is used. You can see the flow diagram. This is the flow diagram used for the phenol production by toluene oxidation process. Here the process is two-stage air oxidation process is used. In the first stage, fresh plus recycled toluene is mixed with a small quantity of cobalt naphthenate catalyst is then charged to the reactor, which is a liquid filled tower through air is sparged. Cooling tubes are provided in the reactor to remove the exothermic heat of reaction. The reactor is operated at a temperature of 150 and 3 atmospheric pressure. The excess air is used, but the toluene conversion is limited to 40% to avoid excessive side reactions. After reaction, several products are formed, including undesired impurities such as benzaldehyde, benzyl alcohol, benzyl benzoate, carbon monoxide, and carbon dioxide. With conversion of toluene at 40%, the yield of benzoic acid is about 90%. The reactor is facilitated with vent after cooling and partial condensation of the mixture, hydrocarbon vapor stream. The liquid product from the reactor then enters a distillation column which operates or which separates toluene from the other organics. The organics then enters a hot water wash unit where extracts hot water extracts where benzoic acid dissolve. All other impurities do not dissolve in water and leave the wash unit as heavy ends. The benzoic acid rich hot water stream is sent to a crystallizer where benzoic acid crystals are formed or crystallized. The benzoic acid crystals are once again washed with water to obtain benzoic acid crystals. The benzoic acid crystals are then melted and fed to second oxidation reactor, where oxidation reactor is fed with air and cuprous benzoate catalyst. Steam is also added to the reactor so as to enhance the temperature of the reactants quickly. Cooling is facilitated by using a jacket or cooling tubes. The reactor conditions are a temperature of 220 degrees Celsius and a pressure of 1.3 to 1.7 atmospheres. The excess air is again necessary to get a 70 to 80% conversion of benzoic acid with a yield of 90% phenol. The overall process yield for the steps is about 80%. The vapors enters a fractionating tower which separates the unreacted benzoic acid from other compounds. Top product is obtained after partial condensation followed by phase separation. The phase separator produces three streams, namely the vent stream that consists of nitrogen, carbon monoxide and carbon dioxide, the aqueous water phenol stream and organic crude phenol streams. The crude phenol stream is partially sent as a reflux to the fractionator and withdrawn as the product as well. The product from the bottom is sent to second oxidation tower or reactor, which consists of organic compounds and is sent to water wash. After water wash, heavy compounds such as tar are removed and phenol is dissolved in water. This water phenol mixture is mixed with the water phenol mixture obtained from the fractionator separating benzoic acid. The crude phenol is fed to a fractionator to obtain purified phenol as bottom product and phenol water mixture as a top product. The top product here is an azeotrope. The phenol water coming from the three different sources is allowed to enter the distillation column that generates water waste as a top product and the crude phenol stream as a bottom product. This is the process taking place in the production of phenol by two-stage oxidation. Next we will discuss about the another process, that is phenol using hydrochlorination of benzene, or it is also known as Raschig process for phenol. Let us see the chemical reactions. Chemical reactions. So these are the chemical reactions taking place in the rashing process or hydrochlorination of benzene process. Here benzene is chlorinated with hydrogen chloride and oxygen at a temperature of 240 degrees Celsius in presence of ferric chloride and cuprous chloride as catalyst to monochlorobenzene. This monochlorobenzene is then hydrolyzed in the second step with water at 350 degrees centigrade temperature in presence of silica catalyst, which converts into phenol C6H5OH and hydrogen chloride, which is actually recycled for chlorohydrogenation, hydrochlorination reaction. Hydrochlorination reaction ಅಲ್ಲಿ ಅದನ್ನ ಮತ್ತೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ನಾವು ನೆಕ್ಸ್ಟ್ ಇದಕ್ಕೆ ನಾವು ಮಾಡಲಿಕ್ಕೆ ಹೇಗೆ ಫ್ಲೋ ಡಯಾಗ್ರಾಮ್ ಹೇಗಿದೆ ನೋಡುವ. So this is the flow sheet for the manufacture of phenol using hydrochlorination route. Hydrochlorination route ಯೂಸ್ ಮಾಡಿ ಹೇಗೆ ಮಾಡ್ತಾರೆ. The rashing process has two vapor phase catalytic stages. Two vapor phase catalytic stages. Right? Purified benzene is fed. Benzene is purified and fed to a heater and packed reactor containing ferric chloride and cupric chloride catalyst. Here, the benzene is extracted to remove the water from that. Then it is purified, and purified benzene is fed to hydrochlorinator reactor where ferric and cupric chloride catalysts are used. Chlorination with hydrogen chloride oxygen is carried out at 220 degrees centigrade temperature, which occurs with a short residence time to produce 10 to 20% conversion of benzene to phenol. This fractionation, monochlorobenzene. The fractionator separates. This fractionator separates the unreacted benzene and chlorobenzene from polychlorobenzene. The crude chlorobenzene is scrubbed with phenol, water washed, and is sent to second stage catalytic reactor. This one. Here it is hydrolyzed in a tubular high temperature furnace with either silica or calcium phosphate as catalyst. Phenol from the hydrolyzer is washed with water, then extracted by benzene and finally purified by two hydrolyzers. In two-stage distillation. Hydrochloric acid vapors from this high temperature catalytic hydrolyzer is recycled to the hydrochlorination stage. ಇಲ್ಲಿಂದ ಏನು ನಿಮಗೆ ಸಿಗ್ತದೆ ಕ್ಲೋರಿನ್ ಅದನ್ನ ಇಲ್ಲಿ ಹೈಡ್ರೋಕ್ಲೋರಿನೇಷನ್ ಗೆ ರೀಸೈಕಲ್ ಮಾಡ್ತಾರೆ. ಹೈಡ್ರೋಜನ್ ಕ್ಲೋರೈಡ್ ಇಲ್ಲಿ ಲಿಬರೇಟ್ ಆಗುತ್ತೆ. ಇದನ್ನ ಮತ್ತೆ ಮೇಕಪ್ ಎಸ್ಎಲ್ ಜೊತೆ ನಿಮಗೆ ಹೈಡ್ರೋಕ್ಲೋರಿನೇಟರ್ ರಿಯಾಕ್ಟರ್ ಗೆ ಕಳಿಸ್ತಾರೆ. Right? So this is the process taking place in phenol production by rashing process or hydrochlorination route. Let us see some of the MCQs in this session. Question number 1. Cumin is made by alkylation of benzene with dash. Option A, acetylene. Option B, ethylene. Option C, propylene. Option D, butylene. Option C is the right answer. It is alkylated with propylene. Second question. Oxidation of cumin is carried out in presence of air in an aqueous emulsion stabilized by an alkali such as dash. Options are sodium chloride, option B sodium hydroxide, option C sodium carbonate, option D sodium sulfate. The option C is the right answer, sodium carbonate. Question number 3. Cumin peroxide is cleaved in an acidifier containing 10 to 25% of dash. Options are hydrochloric acid, option B sulfuric acid, option C nitric acid, and option D phosphoric acid. Option B is the right answer, that is sulfuric acid. Question number 4. The catalyst used in the oxidation of benzoic acid to phenol. Benzoic acid to phenol. Options are cuprous chloride, B cuprous sulfate, cupric benzoate, cuprous aluminate. Option C is the right answer. Fifth question. Hydrolysis of chlorobenzene takes place in presence of dash catalyst. The options are option A silica, option B chromic oxide, option C ferric oxide, and option D alumina. The correct answer is option A, that is silica, is the correct answer. Thank you.